QCM product manager. And I'll start the presentation. Sorry for random transitions that pop up. Why measure moisture? Moisture in a process gas stream causes trouble in manufacturing operations and quality control procedures. Moisture affects the physical, chemical, and electrical properties of virtually everything. If it goes undetected, moisture can affect product quality and lead to process downtime. Moisture analysis in process gas is critical. Maintaining optimum level of moisture. That is critical because it minimizes pipeline equipment corrosion, minimizes line freezing, improves process yields, improves process quality, lowers plant operating costs, and also can slow down catalytic degradation. One thing was, I don't know whether I should go over a little bit about the principles of QCM, because a lot of you are very, very familiar with it. What's the consensus?
Joe, I would cover it just since we're recording the session. Might as well cover it.
QCM technology is basically we are measuring the frequency, the quartz crystal frequency, when we have sample gas, which is wet gas, and dry gas, sample gas that is actually dried by the reference dryer. We have two crystals, one, the measuring crystal, and the reference crystal. Both crystals actually beat at 9 megahertz. And you will notice that the reference crystal is at 9 megahertz, whereas the measuring crystal is slightly lower. This is because the measuring crystal is coated with a polymer that is hygroscopic material that absorbs moisture and changes the frequency. So, as I said earlier, the principle is measuring the difference between dry gas and wet gas. So when we have wet gas, we have a frequency, which is the wet cell frequency. When we are measuring dry gas, we have dry cell frequency. And you will notice that the dry cell frequency is slightly lower than the wet cell frequency. The actual measurement is the delta frequency, which is the difference between the dry gas and wet gas. And the delta frequency equates into the amount of moisture you have in your sample stream. The QCM has 3 paths. As I said earlier, the sample path, where the sample gas goes to the sample cell, and the reference gas path, where the reference gas goes through the dryer that gets dried down and goes to the sample cell, where you're measuring the difference between the dry gas and wet gas. QCM has a 3rd path, which is the moisture generator path, where we have a NIST traceable calibrated moisture generator. And when you are running verification on it, you are measuring the wet gas, which is the gas going through the moisture generator, and the dry gas solely going through the dryer only. And that gives you the value of the moisture generator. Here I'll turn it over to Jochen, who is the expert.
Hi, good morning, good afternoon, good evening to everybody. So some of you may have heard my name. I'm based out of Europe. I'm working with this application for the last almost 3 decades now. And we'll try to share in the next couple of slides a little bit of the experience I've come across with customers in the last couple of years, and yeah, try to work out what applications can we cover with to measure moisture in gas. When we say measure moisture in gas, and please go the next slide, Daniel, while I'm talking. When we say measure moisture in gas, so first, moisture is everywhere. Moisture basically is everywhere. Without water, the Earth would not exist. But is it necessarily something we want to have in the process? I would say more or less no. So there is a lot of applications where you can measure the water. But we in AMETEK process instrument, we don't go for the humidity monitoring. We don't go for the easy ones. We go for the difficult ones. That's our strength, and that's where we want to be in the market. So I was talking to Daniel while preparing that, and we decide to put one slide in at the end, but I have to talk in between about it. Always when we visit customers, first, it's important for us to understand what does the customer want to measure, why does the customer want to measure, and what is the instrument the customer has experience with, maybe what the customer has installed. There's always different technologies, how you can measure, how you can do a measurement for oxygen, for CO, for CO2, for all the components. There is several methods of doing it. As we say in Europe, there are so many ways to get to Rome. And not always one is only the correct one. There are several correct ones. There is one specialty with the water, and that differentiates water moisture measurements a lot from other measurements. Other measurements, as we know them in process analytics, you can calibrate. Moisture, you cannot calibrate that easy. You can, but there is always a if, and we will go a little bit deeper into that even when we talk about today applications, not technology. Jang-Il mentioned already the moisture generator. So what we always have to keep in mind, you cannot get any reliable calibration gas with water in something. There is some there are some gases around, moisture and nitrogen, and there are some companies offering moisture and natural gas. How reliable? I will try to go in between. And anyhow, if there is questions, if there is newcomers here in the presentation, and you are not familiar with the QCM technology, so please approach your regional sales manager and have him explaining to you how the system is working. Okay, so we are concentrating today mainly on some key applications where we are, I call it very solid, selling these moisture analyzers for, and that's in refineries. It's the alkylation unit, and in first place, it's the catalytic reforming, the hydrocracker, the catalytic reformer. Next slide, please, Daniel. So the overall description of the application is hydrogen recycle gas. I've not come a single refinery in my business lifetime which does not have a moisture analyzer for this application. They all have a moisture analyzer for this application. Go next slide, please. So what is the process doing? The process is increasing the octane number of the product, and hydrogen is a byproduct of that, and hydrogen is used to activate the catalyst and to have the catalyst working, but it's highly critical that there is a known specific moisture concentration in that hydrogen. Please go for the next slide. The aimed concentration of that hydrogen is 10 to 20 ppm. I've seen some cases with 25 ppm, but to reach that, if it's too dry, you're losing catalyst performance yield, so you have a quality issue. If it's too wet, it's becoming too corrosive. So the customer has to maintain a known and pre-described moisture concentration, and for that he's also injecting some water into that hydrogen to maintain that level. And sorry for that, can you go back to the previous slide, Daniel? What is also happening during the reforming, at one point the reformer needs to be recycled. So there are several reformers always in a refinery, and one may be on a recycle. During that recycle of the reformer, there is or there will be products in the gas like HCl, like pure chlorine, some other dirts, which really potentially can damage any kind of instrument installed. Therefore, most people isolate their instrument during the recycle of the catalytic reformer and only get back at the point when the unit becomes active again. That's causing some problem. Also, there can be significant change in the stream composition, meaning that we get higher hydrocarbons, that we get really aerosols and liquid hydrocarbons into the measuring system. And as you may guess, that's no good news for any instrument installed. If you get HCl, chlorine, or liquids into the system, that will require maintenance so or so. So what I'm doing when I'm visiting customers, go next slide, please, again, Jungle. For this application, when you see a customer, as I say, there is no refinery without having that measurement installed. I can almost guarantee for that. Something they have. The question is, what does the customer have? And how happy is a customer with what he has installed? For example, if you come across and he is telling you, I have a capacitive sensor from Panametrics, or however they are called now, and I randomly see a good result. Bingo, that is ours. We can propose the best possible technology, and that's QCM. And at the end, we will compare the technologies a little bit. On the other hand, if you meet a customer who is telling you, you know what, I'm changing my sensor every 4 months, I cannot control the process, I'm getting so much HCl I can do, then maybe we have to discuss with the customer a different technology. You always have to keep in mind, we in AMETEK, we have different technologies available, so we have to use what is best for the customer and what the customer wants to hear. Other suppliers have most probably only one system or one measuring principle available. So of course they will tell what is the best on their system and what is bad. So our strength is, and I would really put that as a strength, our strength is that we're having some flexibility, that we can say, customer, tell us, what do you have? What is your expectation? What do you require? So always the most accurate most reliable, and the provable is the QCM technology, because you have an onboard verification source. Catalytic reformer, as I say, is something very critical, and the best instrument to install at a catalytic reformer is the AMETEK Model 5000. See the question, or John, can you read the question?
Jochen, there's a question in the chat. It said, hi, Jochen, thank you for sharing the knowledge. Can you share with us estimated dollar savings to the customer in terms of catalytic lifetime due to good moisture measurement versus poor moisture measurement?
Don't have that number, sorry. If somebody has numbers, please let me know. I never come across this demand of explaining it. Jangil, have you got the question before?
No, actually, I have not. About how much money we can save.
I would say, and I would not put it on the money side, if the catalyst is too dry, you will lose performance of the catalyst. If the catalyst is too wet, you're aging, but I cannot put it in dollar. And to be honest, I have not got the question from a customer before.
But one thing is clear is if the catalyst gets damaged, the cost of replacing the catalyst early is very, very significant.
It goes in the, I would say it goes into the 100,000.
Yeah, or even into the millions, Jochen, I've heard from some customers. But in terms of good versus bad measurement, I like you guys haven't had that question asked of me by a customer.
No, in all my years, no. And there is nobody who needs to justify the measurement, because the measurement is there, and it's also it's already described by UOP, and the main licensor is UOP, and UOP is recommending quartz crystal for that application. Okay, the next big topic in refineries is the alkylation field, the alkylation unit. It's the same question. It's a reactional process which is using liquids and other stuff to have a reaction happening, and the moisture is a clear and significant measurement to guarantee process performance. Next slide. And here it's also a question of protecting the hardware vessel from corrosion, because if the feed is too wet, corrosion of the process units will start. So, and it's also, we have to bring it to the optimum of consumption of acid. So, and lowering the cooling cost. But again, here, I cannot provide any reliable figures of how many dollars we can save by bringing that principle in. And the same points, the measurement needs, or the application needs a reliable measurement. The best and always the point which makes a measurement reliable is that I can guarantee the accuracy or the reading. Always you come across, when you talk to people in the refinery, you have that classical battle between instrumentation and process people. Process people always say that reading cannot be true. Instrumentation say, hey, listen, my instrument is always okay. The reading is true. How to prove it? With the QCM technology, you have the online verification where you have a certificate against, where you can say, see, I show you my instrument is right. How to do it with other principles? That's a big question mark. How you want to prove that your reading is correct when you don't have a moisture generator on board. That are the two main applications in refineries. Yes, there are more applications, but those are the two which are there in every refinery, and where you will find a moisture generator, a moisture analyzer for sure. It's the question, what does the customer has? How happy or how satisfied is he with what he has installed? Then we can understand if he is happy, all is fine. Let's take the next generation or take the next unit. If he is not happy, which is likely to happen, then we have to understand what is missing. Why is he not satisfied with the unit he has installed? And how can we help him to have the unit operating better? Any more questions to that topic before I go for the next one? I see no. So next one is moisture in petrochemical. As I understand, we will have a separate session about petrochemical unit, about ethylene cracker. But let's talk and concentrate here on moisture. Can you take the next slide? We want to concentrate on moisture applications today, even when I will mention some other applications which are happening here. So for petrochemical, moisture is critical for the manufacturing, for the storage, for the distribution. It's also critical for the process performance, for the quality of the product, and protecting hardware, the equipment of the process. So there is several aspects why moisture is so important in petrochemical application. One of the biggest applications there, we have the ethane cracker. Next slide, please, Django. And here for the ethane cracker, as I say, we will have a separate session for that, but it's the most attractive unit, process unit we can go for. You have moisture analyzer, you have ethylene analyzer, and you have oxygen analyzer for the cracking furnace. So there is a lot of applications we from AMETEK process instrument can do. So, but as I say, we are concentrating today on the on moisture application. Go to the next slide, please. So we have the feed gas pipelines, we have the ethylene, the propylene, the ethane. It has to be, the moisture level has to be guaranteed during various process steps. And also there might be a custody transfer point where the producer is selling his product to somebody. It can go on a rail car, it can go on a street car, different ways. It can go into a pipeline. So at one point, the manufacturer has to guarantee the quality of his product, and therefore moisture is a highly important quality measurement. And the moisture concentration in that is low. The moisture concentration here is definitely in an area below 5 ppm. And when we talk low measurements, it's becoming more critical, and I'm ready to make the statement, I don't know any other reliable process instrument working on a different principle than QCM to make that measurement reliable and accurate. The higher point is on reliable, and make sure that the instrument is reading what we want to see from the instrument. Go to the next slide. So there is also catalytic beds in there where we have to make sure that the hardware is protected from potential freezing on the cold box. Next slide, please. And as I've said, we have to maintain a moisture concentration here, which is approximately below 5 ppm. In most cases, it's around 1 ppm. So you need an instrument capable of doing that. And in my view, only QCM is capable of doing it, plus QCM plus the moisture generator is the right setup to make sure that the reading of the instrument is not a debatable thing between instrumentation and process control or customer and consumer. We also have to understand that a lot of people will stretch their specification. As I have said, if you have only one instrument to sell, of course, you try to make it as a salesperson. You try to make it as good looking as possible. So you will compromise, you will stretch. The strong points for us is, again, we have the online verification. Plus, we have to understand that only the AMETEK QCM instrument has a baseline, a zero line compensation, as we use it in our models SLR and TE. Other manufacturers do not have that feature. So in the petrochemical plant, there are several applications. It's a very nice customer base. It's a very nice application, and you will find a lot of requirements to measure moisture and oxygen and. So it's a highly attractive process to go to. And also here, same as in catalytic reforming, you can be sure something the customer has installed. And like with every installation, we have to understand what the customer has installed. Is it working? Is it not working? In case it's not working, before we make any other proposal, we better understand why something is not working before you fall into that trap and go, fall into the same trap than others. So our strength is with understanding what is there and then coming with a solution to what the customer is expecting from a reliable manufacturer. Next one, please.
One thing, Jochen, I just like to go back to the other slide. I'd like to talk about polymerization, specifically gas phase polymerization reactors. There is more use of low-level moisture analyzers like the DO. It's specifically used for N2 purging of the reactor before the process starts. They use the moisture level that is coming out of the reactor to monitor whether the reactor is clean enough. Also, the monomer gas that is used, ethylene or propylene, for that reaction, they measure the moisture. One other application that came up and has become a disaster is the recycle stream on this polymerization reactor. Whether it is they need the QCM because of the low-level moisture, but the presence of titanium chloride in low amounts in the recycled stream is detrimental to any analyzer. So that is one application that we have to stay away from. Sorry.
Thanks, Daniel. Yeah, I saw some communication. To be honest, I've not come that much across with that, good or bad. Yeah. The good ones are the ethylene, propylene, loading, manufacturing, cold box, all these applications. Low level and performance is critical. Okay, let's come to natural gas. Natural gas is getting more and more important, and transport of natural gas also is a critical thing. And what you don't want to have under any circumstances is moisture in your natural gas pipeline, because it can cause pipeline corrosion, it can cause freezing in the pipelines, it can cause hydrate forming in the pipeline. So all the stuff you don't want to happen. It can damage compressor station, and it can finally also damage the pipeline, and it can cause freezing. There is areas in the world where the dew point of natural gas in the pipeline, like when we go to the south, and for example, when I talk in the tropical regions, they are not coming across to pipelines which are operating at minus 30 degrees C, but I'm sure in Canada, in parts of Asia, in Russia, this is an issue. So it's also a little thing to check in which geographical area are we talking, and that's dictating the performance or the specifications for the pipeline performance. So going through the various applications, next slide. So we have the dehydration unit, the dryer unit, the separator unit, the natural gas liquid, the NGL recovery, the transportation of that. So we have different steps. So the first one is the dehydration. Next slide. That's the MOLDIF dryer or the TEG dryer. And simply, they are there to dry the gas. Wherever it comes from, it can come from underground storage, it can come from the field. So the gas has to be dried and has to go under the given specification. It has to go into the pipeline grid. And when we talk about natural gas pipelines, it's always interesting to see what is required by the operators of the pipeline network. Is there a common overall specification written for that? Again, that's different by geographical area. So we have the dehydration, we have the MOLDIF dryers where moisture measurement is a must. Then we have the natural gas liquids where we have a turbo expander where the gas, next slide please, where the gas has to be ultra dry before it hits the turbo expander, which has a surface temperature of minus 110, minus 120 degrees C. So that's where the other gases is getting split off. Moisture measurement for that is ultra critical, ultra important, because when the turbo expander freezes, it cannot operate, it cannot produce, so it causes then process downtime, and it's ultra critical. And this is a ultra low. The measurement will be for sure below 1 ppm. And again, you need the QCM technology and you need the correction for that. Okay, next slide, please. In summary about natural gas pipelines, we have pipeline transition, we have custody transfer points, we have compressor stations, we have storage. And when we go into storage, storage can be different. Storage can be in storage tanks. Storage is mostly in underground storage. In some areas, the reservoirs where they store natural gas have been used, can be used for oil before. It may be that it is salt domes where they win the salt when they wash the salt out from underground. And so it's highly potential that the moisture may increase, that the moisture reading is high, that the gas has to be dried. And for all of that, the measurement of moisture in the natural gas is a critical component. And we're coming more and more across bioethanol injection into the gas. In a lot of areas in the world, 10 to 20% of natural gas, of any energy, need to come from renewable sources like bioethanol, from grain, from corn, from whatever, from farm, whatever. And this gas also potentially is wet, and it has to fulfill the pipeline specification because before it goes into the pipeline grid. So every small producer of bioethanol, of biogas, has to fulfill the quality specs of the gas before it's injected. So there is a wide market, a big market for additional measurements, because before you get 10 or 20% of your entire natural gas replaced by renewable energies, you need a lot of small stations. So you find this on farms, you find that on many things. The main customers for that are not the single users, it's the producer of those units, the producer of the compressor stations, because when it comes from a fermenter, the gas needs to go through a compressor and gets pumped up to the pipeline pressure. So this is a good application. Moisture has to be measured. Other components have to be measured as well. So there is a lot to sell. Next slide, please. One gas which I want to pay some special attention is moisture in CO2. There is not that many, or I would say it's almost the most corrosive mixture you can build, water and CO2. Why is CO2 so important? CO2 is widely used in the industry. For example, all the drinking industry is using a lot of CO2. Also, we have to consider that CO2 needs a special treatment of the QCM sensor. And it looks that other manufacturers of QCM sensor don't understand how to do that. So if you convince a customer that QCM is the best technology for that, then you are exclusively and you are alone on that playground. So CO2 producer and CO2 consumer and everybody who is applying CO2 to the food industry is a potential client. Okay, next slide. I was mentioning it several times. Of course, you can do some of the applications I just described. You can do with capacitive probes, you can do it with quartz crystal sensor, and you can do it with laser. A lot of people think the latest innovation of the globe is laser. Is it always the best? Don't know, not necessarily. What do we have to consider as AMETEK? If a customer is not, as I say, if a customer is not happy for whatever reason with his installed instrument, I would not go and offer him the same instrument again, whatever it is. There is some application like the reform or recycle gas, which is critical, which is dirty, and there can be process conditions that the quartz crystal sensor gets contaminated frequently. Yeah, then let's go for the laser. But what does it mean when I say then let's go for the laser? I always say if I open an application for laser, I invite 5 to 6 other companies. Laser almost is laser. Everybody has its specifics, but laser is laser. If I'm succeed to keep an application for QCM, then it's us or Michel, only 2 manufacturers offering the QCM technology. Why QCM has his advantage, and it goes clearly with the online verification. Only the QCM analyzer has the online verification built into the system. So the customer wants to measure, yes, possible with both. The customer wants to calibrate or verify, then the best technology is QCM with the online verification. And as I said several times, what only AMETEK's QCM analyzer can do is moisture in CO2, proven. The zero baseline correction, what we have with the model 3050 SLR, DO, and TE. The best accuracy at the lower end and the lowest detection limit within the neighborhood of 10 ppb. Okay, so that's the end of my part of that presentation. So I give it back to Jang-Il to summarize.
One thing very important is installation considerations. We have had dissatisfied customers due to bad installation, and usually the first thing they blame is the analyzer. And when you get to the heart of the problem, it is due to installation problems. Main thing, speed of response. It is dependent on the sample system. The length of sample line is very critical. Of course, shorter the better, but sometimes you cannot have short. The specification of the sample line. For low-level moisture, electropolished, also best is 1/8 inch tubing versus 1/4 inch, because 1/8 inch tubing has 8 times less volume than 1/4 inch. And the other, heat trace to 60 degrees C. That's the magic number for moisture. Any higher is just wasted energy. The other thing is sample gas pressure. It is best to drop the sample gas to the pressure you need at the tap, because the lower the pressure, the less volume of sample gas is in the sample line. Also, QCM technology uses very little sample gas versus, let's say, laser. So in order to compensate for the small consumption, it is best to have a bypass or fast loop at the entrance to the analyzer. Another consideration, another thing to keep in mind, this is really important, is to purge the sample system sufficiently before connecting to the analyzer. Do not purge while connected to the analyzer, because all the crap that is in the sample line will go to the analyzer and contaminate it. Maintenance. Before maintenance, isolate the analyzer. And the best way to isolate the analyzer is to close off the inlet and outlet. Not only the inlet, but the outlet of the analyzer. After maintenance, the same thing. Purge the sample system before connecting to the analyzer, because everything that has accumulated in the sample line will go to the analyzer and contaminate the analyzer. Another thing is you have to make sure there is continuous sample flow to the analyzer. If for some reason they stop sample gas flow, you will have back diffusion of ambient air, or if it is connected to a vent system, all the crap that is in the vent go into the analyzer and contaminate it. One last thing is there should be no flow meters or any type of control device on the sample gas flow to the analyzer. As long as you provide the required pressure, which is 20 to 50 psi, the analyzer controls the flow. If you have flow meters or some kind of flow control device, you are providing a restriction pressure drop, and that can screw up the flow control of the analyzer. Also, flow meters like rotometers, however expensive they are or however high grade they will act like a sponge because it has a lot of dead leg. Also, the sealing on those flow meters are not that good, so you will get ambient air coming into the sample line. That's all. I think that concludes our training. Thanks.
Thanks, Daniel, and thanks, Jochen. I'll give a chance in case anybody has any questions, but I'll ask one to start. On the slide before that, I know you guys mentioned a few advantages on what AMETEK's QCM can do. I was just wondering specifically if either of you guys could just comment on, for the audience, maybe on what are some of the better points to make when you're going up against Michel as the other QCM manufacturer? What are some of the key areas you guys typically want to highlight?
Michel has not found the recipe of how to do moisture in CO2. And Michel has not found out or don't want to do it, whatever. They don't have the zero dryer module, so they cannot compensate the zero drift of the system.
So in adding to that, the equivalent to Michel's model of QCM is our 3050 OLV. They cannot do better than our 3050 OLV. Even with the 3050 OLV, we have a better dynamic range, which is 0 to 2500, whereas theirs is at best 0 to 2000, but they also have a calibrated, which is, I think, 0 to 1000 something. So their range is not that good as ours. The detection limit they claim is the same as ours for the OLV. And one advantage they have is their packaging is much newer, so it is more attractive in that sense.
But when you say it's newer, it's smaller, and smaller doesn't mean necessarily it's better.
Yes, yes.
You may need very small fingers to get into something which is smaller. You need to be a doctor and not a process mechanical.
Okay, thank you both for that. If anyone has any questions, you can certainly unmute your phone and give it a second here. I don't see any questions in the chat at the moment. All right, well, Daniel and Jochen, I appreciate the session today, and to all the attendees, thank you for attending. As I mentioned earlier, we will put a recording up of the session within the next day or so. So thank you everyone for attending, and have a good rest of the day.
Okay, thanks.